I'll open up my web browser. Now, typically, I would just use ping to do this connectivity testing. However, by default on the Cisco ASA 5512, ping is explicitly denied. The big reason for that is because ping does not use TCP. Ping uses nothing at the transport layer for a protocol. It's only using IP, and the firewall by default does not have a mechanism to keep track of the ping traffic coming in and out of the device. So ping by default is blocked right now. So we're just going to use a web browser and browse to the websites I have set up until we get to the module where I talk about service policies, and then we'll set up a simple service policy to allow ping through the router so that our users and our administrators can do proper testing of systems. For the time being, I'm going to go to HTTP 198.51.100.100. That is my outside web server. And if I hit enter, I get the web page, and it's just this graphic of firewalls saying outside web server. So I can definitely get to my outside web server from my inside PC. To demonstrate that my inside web server is up and running, I'll open another tab here, and we'll go to 10.0.0.80. That is my inside web server, and I get the same basic website, only I'm identifying this web page with inside web server. So my inside web server and my outside web server are both accessible from my inside PC. Let's move over to the internet PC now and see what type of access that has. I've set the background of this PC to be the same color as the PC in the drawing. If we look at the IP address of this workstation, we can see that it has an IP address of 198.19.42.33. So what I'd like to do is open up Google Chrome, and we're going to browse to 10.0.0.80. And what we should find out here is that this website is unavailable. Now you might be asking, but Ross, 10.0.0.80 is a private address. We're coming from a public address out on the public internet, and the public internet does not route private addresses, and this is true. However, this is my lab environment, and I can do what I need to do in my lab environment, and actually these IP addresses that I'm using, the 198.19.42.33, that's actually a documentation IP address from RFC 5735 for special use IPv4 addresses. And these are public-like addresses that are not routed on the public internet that we can use for documentation and testing. So what I've done is in my cloud, I've set up so that I actually can route 10.0.0.80 back into my network through my firewall. And I wanted to do this because I wanted to show you how access rules work and how the interfaces work with security levels without having to worry about NAT yet. So we cannot get to my inside network. Let's check to make sure that it is actually working and that I can get to a website. So I'll go to 198.51.100.100 just to verify that my outside web server is active and online. Let's move back now to my inside PC. I'm on my inside PC now, and what I'd like to do is open an SSH session to my firewall. There we go. And before we start this, I want to clear all of my connections for 10.0.0.99, which is my current workstation. And the reason I did that is that I want to see just one of the connections that we're making out to my outside web server, or try to limit the number of connections that we see in my firewall. My workstation is connected to the public internet. Microsoft sends a lot of data to the public internet. Microsoft tries to build Teredo tunnels to get IPv6 connected to your workstation. So by default, Windows in its very nature is going to be sending out lots of information out to the firewall. So you can see even without me making a connection, I'm deleting connections as I clear these, and I didn't even start anything. I have all my connections cleared now. I'm going to open up Google Chrome in an incognito window so that I have a fresh browser, and I'm going to browse to my outside web server. 198.51.100.100. We'll get that website up, and then we'll go back and we'll look at show connection address 10.0.0.99. And what we should see here now is we should see a connection from my workstation to the outside web server. And it looks like I was not fast enough to show you that connection because it is not here right now. Let's try that again. Clear con address 10.0.0.99. We'll open up Google Chrome. We'll refresh that and quickly go back here and show my connections, and there we go. So, couldn't get it the first time. We're really only making one simple connection to this website to download the web page. It's just one image that is the website. So here we can see we made a TCP connection to the outside interface to IP address 198.51.100.100 on port 80. And that came from the inside interface 10.0.0.99, port 56.186. And then this last piece here, the flags. These flags are going to tell us what the state of the connection is. Now, I don't want to go into the deep dive detail of what all these flags mean, because in the Cisco ASA, they keep track of a lot of little pieces of information. But just know that these flags are what's keeping track of the current state of the connection between my workstation and the outside web server. This state table is the exact thing that is allowing the traffic back in from the outside web server into my computer. That state table, as we saw, does not last forever. The state table times out. So if I show that state table again, we will not see a state for the connection between my workstation and the outside web server. The outside web server can no longer send data into me. Well, what are these other connections, these UDP connections? Well, the top one there to 8888, that is Google's DNS server. Port 53 is DNS, and it operates on UDP. And this other UDP connection, this is a Microsoft connection to build a Teredo tunnel so that I can have IPv6 on my workstation. We're just going to, like I said, ignore that for the time being. So there is our TCP state table.